Alright, so today I'm going to show you how to form the tangent lines between two arbitrary circles. I'm going to call this circle A and this circle B. And notice they're completely random arbitrary circles. Nothing special about them. To start out, let me show you what we're after. We're after the tangent lines of the circles. And a tangent line is simply a line that's coming off of the circle exactly one point. So what we're after is we're after a line like this, something like that, that will touch both circles at simply just one point. And see, it's just, you can't just eyeball it. So I'm going to show you how to find that, as well as the one on the opposite side, so both the exterior ones and the interior line, so that and that. So that's what we're after. So let me show you how to do it. We're going to start with a segment in between the centers of the circles, and I'm going to find the midpoint, and just for ease I'm going to call this M for midpoint. Now I'm also going to find the midpoint between the edges of the circle. So there's that point, and I'm not going to label it because we're only going to use it for a little bit. I'm going to rotate now circle A around that point. I'm going to rotate it 180 degrees. And it's the same as reflecting. When you get 180 degrees, it's the same as reflecting. You could reflect it off the perpendicular line here, but it's easier just to rotate it around 180 degrees. So you can see this is just A prime, basically. It's just a mirror of circle A. Now what that gives us is the radius coming inward off of circle B. So here's the center of circle B. I'm going to create another circle that cuts circle B with the radius of circle A, that's what this is, that goes all the way around circle B. So now let me hide this and show you what I did. Now this is just to measure, so you can see circle B. Now this is not circle B, this is circle B, and this is just a small circle cutting circle B inward, so that this distance right here is equal to the radius of A. So let me measure that. Length, there you go, and then let me get the distance here, measure that, and voila, they're the same. So you know that this is equal to that, which is what we want. So now, going back to the midpoint, actually, let me go ahead and hide these so that it gets a little full of lots of little lines, so I'm just going to keep it kind of clean for now. I'm going to build a circle off of the midpoint. This is the one I labeled, and it connects to both the centers of the circles because it's the midpoint. So this distance is the same as this distance because it's both the radius of this new circle I just made. And that will give us something in a little bit. But this intersection with the midpoint circle and the radius of circle A cutting into B, that's what this circle is. This intersection makes a line, and now let me show you what that line does. We're going to take the tangent of this line, so the line I've got selected, and this new circle we made inside of B. I'm going to go ahead and construct a perpendicular, right, because that makes the tangent line. You can see this is the tangent line off of this circle, exactly the radius of A inside of B. And you notice this line cuts circle A right in the middle. So, and remember what we're after. We're after a line like this that will be on the outside of B, so somewhere over here, and that is a tangent also with circle A somewhere over here. Well, guess what? We have that point right there. And it's this angle, right? Because we're going to just shift this line this way, exactly the radius of A this way, and that's what this distance is as well, the radius of A. So we're going to just move this down. So I can do this two ways. I can either take the parallel of this angle, because I know that that is the correct angle of a line, or I can just do the tangent line, the perpendicular off of this point, and show you that that works as well. So there it is. It hits exactly at one point. Let me move this so you can see. So now there's one we've got, and we don't even need to build this line on the other side, so I'm going to hide that one, and we know that this is the point. See, it's the same, and I'm just going to take the tangent line from this, so the perpendicular like that, and there you go. It hits both circles at a tangent. So there's the tangent lines on the outside. So let me hide this stuff, and I'm actually going to hide this interior circle because we don't need that now. But you can see that these two work, and I'll just do a little drag movement so you can see that they stay. Now when it collapses is when circle A becomes larger than circle B. You can see this circle, that's the radius of A right there. This distance right here is still maintained. So when A becomes too big, if you can picture that little circle inside, it's suddenly on the outside of B, and you notice that the tangent lines collapse. So make sure that circle A stays smaller. So now we're going to do the same thing, except we're going to do it on this circle opposite. We're going to make this radius, we're going to create that radius all the way around A in a big circle, and we're going to find the intersection with the midpoint circle, and that line should hit B in the center. So let me go ahead and do that. Now to find that intersection point, I'm going to take a segment from the edge of circle A to the center of circle B, and then I'm going to create the midpoint. So that's this new point right there. And now I'm going to rotate circle B around that point 180 degrees like last time. I'm really just reflecting it around that point. 180, rotate. There you go. So now the center of the reflected, the mirror version, or B prime, is right there, hitting the edge of circle A, which is what we want. And that gives us this is the radius of circle B. And what we want is we want a new circle now, starting from the center of A, that gives us A plus the radius of B all the way around A. So there's that point right there. And now we've got it all the way around circle A, and I'm going to go ahead and hide this so it doesn't get cluttered. Clean that up a little bit. And I don't need those anymore. Hide those. And now let me just measure to verify that I did that correctly. There's that. And we're gonna measure this distance here. Like that. So I to J is 6.7, and then also the radius of circle B just happens to be the exact same. So there we go. We've done the opposite. So remember, on B we created a small circle inside that gave us the radius of A inward of B, and now we created a larger circle around A that gives us the added radius of B. So you take the radius of B and you add it going out. So there's that. Let me get rid of those for now because we don't need to see that. I just wanted to show you what that was doing and the reason behind it. So now, again, we need to reform. I hit it just to get it out of the way, but we're going to reform our midpoint circle. So there it is. There's our midpoint, and it's hitting both circles at the center. And now we're going to take the intersection of this, the center of A, all the way to that intersection of the new circle, the big circle around A, and the midpoint circle. And that gives us those points. And now let me show you the tangent of those points. So this line here, this radius of this new larger circle, and actually I'm going to hide this midpoint circle so it's not in the way, confusing you. I'm going to take this segment, and at this point I'm going to get the tangent line. Now if I did this right, it should hit the center of B. So let's go ahead and construct the perpendicular. And there we go. So the tangent of this new circle hits the center of B. So now what, and it does the same on this side, but I won't do that quite yet because it gets confusing. Now what we want is we want to take this line at this angle and we want to move it this way, exactly the radius of B. So we're going to take it that way and we're going to take it that way, and have the same angle, so that is this distance, which I created already. So I'm just going to go ahead and do the well, actually I'll show you that it's really this angle, so I'll just do a parallel. Parallel to that is the tangent line that hits there. Now before I create the point, I'm going to get rid of some stuff, but I want to do it on this side first. So there's that, there's the point. I don't need to create this line, which is that same as that one. I'm just going to do the tangent line off this perpendicular. You can see it works both ways. Okay, so it hits there and it hits there. So now let's hide some stuff so we can see what's actually happening. Let me hide this bigger circle. We already hid the midpoint circle. And then we don't need this. We don't need that. Hide those. We don't need that. There we go. And this point and that point. Hide those. Okay, so now what you can see is that we've got the two tangent lines, and they're on the inside now. And let me just form the points right there and right there. And to verify that these are indeed tangents and they're only hitting the circles at one point, this line coming off of the radius of B should be a 90-degree angle. It should be perpendicular to this. So let me just measure this angle to prove that it's indeed 90 degrees. Okay, there we go, 90 degrees. So that means it is indeed a tangent line. So now let me hide this. And so you can see that what we've created here is in fact all the lines that are tangent to both the circles, and that's this line, this line, this line, and this line. So you've got two exterior tangent lines and also two interior lines. And then drag test, you can test this out that it stays together. It stays all together until circle A becomes bigger than circle B, and then you can see that they collapse. And you can also notice that as circle B becomes closer to circle A, as they almost touch, the two interior tangent lines would become a straight line once they touch, which is what you'd expect. So hope you've enjoyed. Thanks for watching, and now you know how to make the tangent lines for two arbitrary circles.